Hello everybody, here we are, 8.3, number of solutions for systems of linear equations. The notes, this time I just put a graphic in there for you and I'll go over it now. So for intersecting lines, doesn't need to be perpendicular, just any intersecting lines, there's one solution. So one point at which these two cross and a solution, that makes each of these true. They have different slopes. And the y-intercept can be the same or different. We could have, a line that goes here and passes through. Well, I didn't quite make it the exact same y-intercept. That's okay. They could have a solution at the same spot, but they need to have a different slope if their y-intercept is the same, or else we're going to get something else, which I'll show you in a second. For parallel lines, they have no solutions. They have the same slope and different y-intercepts, and they just travel alongside each other on and on and on, and they never quite cross, so they have no solution in common. And the last one we call coincident lines or coinciding lines. So they have an infinite number of solutions. You might see it as like infinitely many solutions. You might see it written like that. So you might see it listed as infinitely many solutions. Infinitely, there we go, many solutions. And, is this two lines or is this one line? Hard to say. But that's the kind of situation that I was talking about or alluding to, in which we have kind of two lines or kind of one line, but it's the same. And this is when we have the same slope and the same y-intercept. So for each of the questions, we're going to be graphing these or just examining these linear systems and seeing, do we have one solution? Do we have different slopes? So they intersect once? Are they parallel and so they don't intersect at all? Or are they actually the same line and so they have infinitely many solutions? So let's do it. Find the number of solutions for each system of linear equations. Justify your answer. So these ones we can see they have the same y-intercept. They have a different slope. Based on that info up there, I think we're going to have one solution. So we have, different slopes. Same y-intercept. Therefore, one solution. But let's graph it as well. So we're going to start down at -1. Our first one I'll do in blue, -1, and then we have a slope of 5. So we're going to rise 5, 1, 2, 3, 4, 5, and run 1. Rise 2, 3, 4, 5, somewhere about there. And 1, 2, 3, 4, 5, about there. Is that 5? 1, 2, 3, 4, 5. Yep. Okay. And I'll make it into a line. Not a very straight one, but you get it. And our next one, we start also at -1, and then our slope is -2/1. So down 2, right 2, moving in the opposite of our check mark. So a negative slope like this, and our line looks like that. And you can see that they have one solution at this -0, -1 mark. C graph, 0, -1 is our one solution. Okay, let's look at our next one. We have one in slope-intercept form, so we can graph that. And then let's convert our other one. So we start at +5, 1, 2, 3, 4, 5. Our first dot at the y-intercept. Then our slope is going to be rise over run. 1, 2. The other way, this way. 1, 2. Looks like that. And our next one, let's convert it. Let's keep our y on this side and move the x's over. So 2y equals, let's plus x, and let's plus 10 to each side. X plus 10. Okay, and now we want the y by itself. So let's divide by 2 on each side. and we will get y equals 1 over 2x plus 5. And then from there, you can see we have now the exact same line. We have intercept of 5 and a slope of 1 over 2. So I don't know if I'll be able to show this that well, but our lines are exactly the same. So we could have same slope, same y-intercept, same formula, same equation. So we have infinitely many solutions. The call's coming from inside the house. These are the same lines. So is this one line? Is this two? Hard to say. Let's do our next one. We have our first one in y-intercept form. So let's graph that first. We are intercepting at -1, and then our slope is rise over run 4 over 1. 1, 2, 3, 4, 1, 4, 1, down 1, 2, 3, 4, 1. So it looks like that. And this one, let's convert it. Let's move our positive. I'm going to move our y so that it's positive plus 2y. 4x subtract 6 equals 2y. I added 2y to each side. And now let's divide by 2. And what do we get? Y equals 2x subtract 3. And let's see, we got, I thought they would give us one of each. I thought we were going to have a parallel line, but it turns out not. Let's do -3. 1, 2, 3 is where we start. And then our slope is 2 over 1. 2 over 1, 2 over 1, 2 over 1, 2 over 1. And the other way down like that. And so we have different slopes. Different y-intercept. So it could be the same, could be different, but we end up with one solution right there. Okay, and I'm surprised we got one solution, infinitely many. I thought that probably in our notes we should have one that are parallel, and then we would have no solutions, but maybe I'll change the notes. But maybe I should say, imagine this had been an 8x, then we would have had same slope, different y-intercept, and we would have had no solutions. So let's look at this question. And this is kind of like trying to think about what are the conditions that give us one or the other. So in the system of linear equations, y equals 4x subtract 1, and then our formula, or y-intercept formula, what values of m and b will result in a system that has no solutions? So what would we need this m and this b, what would they need to be in order for us to have no solution? So we need these lines. These are going to be then parallel. So what do we need for parallel lines? We need same slope. So m has to equal 4. And then, but they need to not be the exact same line. So, need different y-intercept. So b cannot equal -1. Because if we had the same slope and we had the same y-intercept, then we would just have the same line. And we would have down here an infinite number of solutions. Okay, what about to have one solution? So what do we need here? We need to have intersecting lines. So they need different slopes. Because remember, if they're the same slope, they're going to be parallel. So m, or our slope, cannot equal 4. So it can be anything other than that. And then no real restrictions on B. Our lines, for example, could be, here's one line like this. We could have a line that's, incredibly close to it, but it does cross at some point. We could have, a line that's like perpendicular. So they could be crossing at different intercepts, and maybe they'd be intersecting like way down here, way off somewhere. I guess I would, maybe say B equals a real number, but I don't even know if that's going to help you. No real restrictions on B. Um, it's okay if it has the same y-intercept. And for an infinite number of solutions, we need to have the same slope, and we need to have the same y-intercept. So m needs to equal 4. So b has to equal -1. So it has to be the same. It has to be the exact same equation for this line. We have to have the same slope. We have to have the same y-intercept. Thank you so much. I'll let you know what textbook questions I'd like you to do.